Hey everyone, welcome to The Explainer. Today, we're getting right into Send.Win's 2026 guide on DOM reconstruction browser isolation. Look, if you've been agonizing over how to lock down enterprise web traffic without totally wrecking your users' sanity, you are in exactly the right place. Let's get right into it.
Okay, here is our roadmap. We've got a 6-part journey today. We'll start with the isolation middle ground, peek inside the sanitization pipeline, tackle the JavaScript challenge, weigh the pros and cons, pit DOM against pixel pushing, and wrap up with the cloud browser future.
All right, Part 1, the isolation middle ground.
So in enterprise security, we've always had this unavoidable tug of war, right? Strict security versus a smooth user experience. Lock things down too tightly, and productivity just dies. Leave things too open, and, well, you end up on the front page of a tech blog for all the wrong reasons. Enter DOM reconstruction browser isolation. It's kind of the architectural hero here. Basically, it renders a web page on a remote server, sanitizes the document object model, or DOM, to strip out any hidden threats, and then reconstructs a totally safe version for your local browser to render natively.
I like to think of it as the Goldilocks of web security. On one extreme, you've got pixel pushing. It streams rendered pixels like a video. Sure, it gives you a flawless physical air gap, but man, it is heavy. It kills the UX and introduces crazy latency. On the totally opposite end, you've got network layer filtering. Feels native, super lightweight, but the bypass risk is massive because all that code is still running locally on your machine. DOM reconstruction, it sits right in that just right middle ground. You get strong protection without making the web unusable.
Moving on to Part 2. Inside the sanitation pipeline.
So how does it actually pull this off? It's basically a highly advanced decontamination chamber. Picture a security robot intercepting a super suspicious letter meant for you. First, it intercepts and loads the page remotely, grabbing the whole DOM. It reads it carefully, sanitizes elements by spotting potential threats, and then, here's the cool part, it copies only the safe text onto a brand new, clean piece of paper, reconstructing it safely. Finally, it hands you that pristine copy to view natively. Any clicks or typing you do after that are proxied safely right back through that exact same chamber.
And it is incredibly surgical about this. It processes every single web component based on its specific risk level. Take inline JavaScript. That's flagged as a critical risk, so it gets ripped out entirely or swapped for a safe proxy. Iframes? High risk. They get recursively isolated. Basic links are low risk, so the engine just rewrites the URLs to route through the proxy. Literally nothing gets a free pass.
But, you know, every hero has a kryptonite. Part 3, the JavaScript challenge.
Which brings up a pretty massive question. What about modern websites? I mean, think about the apps you use every single day. They aren't just static text pages anymore, right? They're these highly dynamic, real-time hubs, and that makes a static sanitization process ridiculously complicated.
The main culprits here are single-page applications, SPAs, built on frameworks like React or Vue. These sites dynamically generate their entire DOM using JavaScript, so for the remote server to actually sanitize them effectively, it has to maintain a running, mirrored JavaScript environment that catches and sanitizes DOM updates in real time, continuously. That means server-side complexity and compute requirements just go through the roof. It is a huge architectural hurdle.
So let's slow down and talk about those trade-offs. Part 4, weighing pros and cons. Okay, let's look at the real-world numbers, starting with bandwidth, because this is absolutely crucial. DOM reconstruction only needs about 1 to 5 megabits per second per session. Compare that to the massive 5 to 20 megabits you'd burn streaming video for pixel pushing. That's a staggering reduction. If you've got a distributed workforce on spotty internet connections, that's a total game changer.
And the human benefits are just as big. Think back to the last time you suffered through a laggy remote desktop. The jittery scrolling, or my personal favorite, hitting Control F to search and it just outright fails. DOM reconstruction completely fixes that. You get native scrolling, crisp native fonts, full screen reader accessibility, and native text selection. Oh, and since you aren't doing heavy GPU video encoding, your server costs drop significantly too.
But we've got to be objective here. The vulnerabilities are very real. The biggest risk? Sanitization bypasses. Attackers are relentlessly coming up with mutation XSS, HTML smuggling, and polyglot attacks just to slip past these engines. It's a never-ending cat-and-mouse game that requires intense engineering from vendors. On top of that, you can run into visual quirks. Things like WebGL 3D graphics or complex canvas elements often struggle to render perfectly after being reconstructed.
All right, shifting gears. Part 5, DOM versus pixel pushing.
Let's put these two heavyweights head-to-head. Organizations have a clear strategic choice to make here. If you're aiming for moderate infrastructure costs, say $5 to $12 a user per month, with near-native UX and low latency, DOM Reconstruction is absolutely your winner. But if your specific threat model absolutely demands the highest possible security guarantee, a true physical air gap, and you can stomach up to $15 a month, the noticeably higher latency and the degraded UX, then you've got to go with pixel pushing.
Because it strikes such an attractive balance, DOM Reconstruction is heavily adopted today. Looking at the 2026 landscape, the heavy hitters include Menlo Security with their isolation core, Cloudflare's Zero Trust, Zscaler's Zero Trust Exchange, and Ericom, which is part of the Ericsson portfolio now. We're talking about massive platforms processing billions of web sessions. This tech is undeniably enterprise-ready.
But technology never stands still, right? Let's hit our final section. Part 6, the cloud browser future.
The smartest platforms in 2026, they aren't actually locking themselves into a single architecture anymore. They're using adaptive isolation. This means they dynamically pick the isolation method on the fly. Reading a standard news site, you get the lightweight DOM reconstruction. But the second you click a sketchy link from an unknown email, boom, the system instantly adapts and drops you into full pixel-pushing isolation. It optimizes instantly to perfectly balance security and usability.
And that dynamic approach paves the way for the next evolution, modern cloud browsers, like Send and Win. See, traditional isolation was basically just a background bouncer, purely there to block threats. Cloud browsers flip the script to actually serve productivity. You still get that core remote infrastructure isolation, but now you get tools to manage multiple accounts, persistent browser profiles, and independent session fingerprints. It actually gives users a secure, dedicated workspace in the cloud.
Which brings us to the real takeaway from all of this. Ask yourself, is your organization's isolation strategy actually serving productivity, or is it just blindly blocking threats? Because if your security tools are just building walls, they're probably just slowing your teams down. It might be time to rethink your posture and demand an architecture that actually works the way you do. Thanks for tuning into this explainer, and keep learning.